shake in the years to come. Are you gonna think it over and how we lived each day with no regret? Nothing lasts forever though we want it to. The road ahead holds different dreams for me and you. Sometimes goodbye, though it hurts in your heart, is the only way for destiny. Sometimes goodbye, though it hurts, is the only way now for you and me. Though it's the hardest thing to say, I miss your love every way. So say goodbye, but don't you cry, 'cause true love never dies. In a year from now, maybe there'll be things we'll wish we'd never said. Maybe in a year from now, maybe we'll see each other standing on the same street corner, no regrets.
Each and every end is always written in the stars. If only I could stop the world, I'd make this last.
Sometimes goodbye, so it hurts in your heart, is the only way for destiny. Sometimes goodbye, so it hurts, is the only way now for you and me.
Now, we would like to explain about the principle of Melvin master sizer and zeta sizer operation on measurement of particle size. As for Melvin master sizer, the technique used is laser diffraction particle sizing. Laser diffraction measures particle size distribution by measuring the angular variation in intensity of light scattered as a laser beam passed through a dispersed particulate sample. Large particles scattered light at a small angle relative to the laser beam, while small particles scatter light at large angles. This is based on Fraunhofer diffraction theory. Fraunhofer diffraction theory is the interaction with particles that causes light to be scattered in a forward direction with only a small change in angle. This theory approximates that the particle is much larger than the wavelength of light. All sizes of particles scatter with equal efficiencies, and the particle is assumed to be opaque and transmit no light. However, some of the approximations are wrong. Thus, Fraunhofer theory is further improved with Mie theory, which completely solves the equation for interaction of light and matter. In Mie theory, refractive indices for the material and medium need to be known. It assumes that the volume of the particles is a projected area prediction. Now, both Fraunhofer and Mie theory is used jointly in the particle size analysis. As for zeta sizer, Brownian principle is used to measure particle size, which it is independent of external variation except for viscosity of fluid and temperature. Suspended small particles are always in a state of motion and they undergo diffusion. Photon correlation spectroscopy analyzes the changing patterns of laser light scattered or diffracted by particles in Brownian motion and monitors the rate of change of scattered light during diffusion.
were standing in the wake of devastation, when you were waiting on the edge of the unknown, and with the cataclysm raining down, insides crying, save me now.
As the image we have shown you just now, for suspension, we can observe that there are black spots distributed freely in the liquid under bright light. That are the solid particles suspended in the suspension. However, when a sample was observed under the polarized light, there will be no longer as dark spots, but yellow crystal appear. This is because the suspended solid particles can diffract polarized light to give a different electromagnetic radiation which appears as light to our eyes, while the liquid unable to do so. Thus, the background shows black in color. For the emulsion, when under the bright light, there are spherical particles which can be identified as oil droplets of different sizes are scattered in the liquid medium. Some air bubbles are present too. Do you see the particles with more regularly shaped compared to the rest? That are the air bubbles. When it is observed under polarized light, the same observation is obtained as the one under the bright light, except the whole image becomes darker. This is because both the droplets and the continuous phase are liquid, and liquid doesn't have the ability to diffract polarized light. That's why we get a darker image. In addition, this is the data for particle size of Gaviscon suspension and Scott emulsion that we measure. The value of average and standard deviation are stated here as well.
There are some differences between a normal and polarized microscope. Firstly, normal microscope use normal light to study specimens, whereas polarized microscope use polarized light to study specimens through polarizer. The polarizer configures the movement of light and forces its vibration in a single direction. Next, in polarized microscope, the light waves vibrate in one direction, but the light waves in normal microscope vibrate in random direction. Next, a light microscope has a fixed stage, but the polarized microscope has a rotating stage. This polarized microscope is specific for crystallography and petrography, which are equipped with a stage that is capable of rotating the specimen about as is. The next differences are: polarized microscope generates clearer image and higher magnification of the specimen than a general microscope. Next, polarized microscopes have a higher degree of sensitivity and can be utilized for both quantitative and qualitative studies targeted at a wide range of anisotropic specimens than a normal microscope. In contrast to normal microscope, a polarizing microscope uses the birefringent optical properties of anisotropic materials to study them.
Polarized light microscope is useful in examining pharmaceutical formulations. By using polarized light microscope, rainbow-colored spots are seen which can be recognized as the solid crystals as seen under the bright light. This is because the ability of suspended solid particles to diffract polarized light to give a different electromagnetic radiation which appears as colorful light to the eyes. The background was appear as dark due to the inability of liquid to diffract polarized light. This has proven that there are particles suspended in the liquid medium, which is a suspension characteristic. Solid crystals do not pack closely to each other but distributed quite distantly from one another. Therefore, this shows that there is presence of dispersed solid in the liquid, which indicates that the liquid mixture is a type of suspension. This has also proven that Gavison is a type of suspension. Under polarized light, large and small bubbles can be observed. It shows similar view as in the bright light, except that it has black background. The bubbles are either spherical or oval in shape, and they are dispersed quite close from each other. The droplets are dispersed in continuous phase and shows that they are oil droplets. The small oil droplets tend to fuse with each other to form larger oil droplets. It appears black as seen under polarized microscope light, which proves that both the droplets and the continuous phase are liquid, since liquid cannot diffract polarized light. Therefore, it shows that Scott's cod liver oil is a type of emulsion. Besides, the average particle size can be measured by using polarized light microscope along with the computer software, that is, the readings taken from different snapshots. By finding out the particle size present, the type of pharmaceutical formulation of a sample can be guessed more accurately.